Here in this video, we are solving a problem from the concept of waves. Let me read out the problem for you first. A transverse wave is represented by a general equation A sin omega t minus kx. For what value of wavelength, wave velocity is equal to maximum particle velocity. Right? Let's go into the problem and try to understand. We know a wave equation can be represented as displacement of the particle equal to y equal to A sin omega t plus or minus kx. He has given a minus kx means wave is progressing along positive x-axis. Though it's not required, just I am telling you that. Now, for what value of the wavelength you want to find out a lambda? Wave velocity. So what is wave velocity? First of all, wave velocity, as we have derived an expression v equal to n lambda, where n is the frequency, lambda is the wavelength. But we don't know in this format, like in the given format is omega t's and kx. So I need to write this wave velocity in terms of this omegas and k's. So here what is omega in the above equation? Omega is say d theta by dt, angular velocity. When one rotation is completed, d theta is 2 pi, dt is the time period. Now 2 pi into 1 by time period can be called as frequency. So omega can be expressed as 2 pi into n. Now you know omega. What is this k? If you remember, we have discussed a relation that phase value delta phi equal to 2 pi by lambda into delta x. This 2 pi by lambda is a constant which is called as phase constant. So how much is that phase constant? K is 2 pi by lambda. Now you know omega as 2 pi n and k as 2 pi by lambda. We need to find out velocity. So let's see what happens if you make omega by k. Omega, as I have proved, 2 pi n. As I told you, k is nothing but 2 pi by lambda. So 2 pi n by 2 pi lambda come to the numerator. 2 pi gets cancels. That equal to n lambda. That is equal to v. So the first point you need to understand is you can express v not only as n lambda, you can also express it as omega by k. That is wave velocity. So I can say wave velocity is omega by k or n lambda. Now he is also saying particle velocity. So what is a particle velocity? The particle in wave is in oscillatory motion or in a simple harmonic motion. We have derived equation for the velocity of the particle in simple harmonic motion as v equal to omega into root of a square minus y square, where a is amplitude, y is the displacement from the main positions. For v to be maximum, he said maximum particle velocity, displacement has to become 0. This y has to become 0. Then v equal to omega into root of a square minus 0 square. Omega into square root of a square is omega a. That is the maximum possible value. Now we know wave velocity. We know maximum particle velocity. He is saying for what value of wavelength, wave velocity is equal to maximum velocity. So this wave velocity has to be equal to the maximum velocity. Doing that will give you the answer that you need. Yes, that implies as wave velocity is maximum particle velocity. We can equate wave velocity as, we can write n lambda, but that's not the format that is there. So we are writing in the format that's available for you. is maximum velocity is omega a. So omega can be cancelled. So 1 by k is equal to amplitude. But as I told you, k is 2 pi by lambda. So 1 by 2 pi by lambda equal to a. So lambda by 2 pi is equal to a. So lambda equal to 2 pi a. That is the answer. That's the option C that's available for you. So to solve this problem, you need to know all these concepts like wave velocity and particle velocity. That's it. That's how we have to solve the problem. Thank you for watching.